On to long division. Polynomial long division. So, gets its own lesson. Now, long division, there's a reason I started you out with a problem that I think you see in 4th grade. Because it's the same structure, the same process. It's just more complicated with more complicated numbers. But let's talk about this process first. If you were dividing 40,422 by 6, do you just go like, got it? No. You have to do it one step at a time, right? One piece at a time. What is that piece? Well, if I'm doing this, I say to myself, well, I don't know that. You say, I don't know that. So I'll just start at the beginning. I'll just ask myself, how many times does 6 go into 40? Right? That's it. That's long division, right? 6 goes into 40 how many times? 6 times. Because 7 times would be 42. That's too much. So 6 times 6 is 36. That goes in. Okay. Now think about what you do next. You put a 6 up here. Then you multiply 6 times 6. You bring it down, and you subtract it. Right? Does that sound familiar? Right. When you do, you get a new number, 4. And then you bring down the next piece, and you get 44. And you repeat the process over and over. Right? Then I say, oh, how many times does 6 go into 44? 7 times. 7 times 6, that's 42. Subtract, that gives me 2. Bring down the next piece. How many times does that go in? Oh, 3 times. 3 times 6, that's 18. That's 4. Bring it down, 42. 6 times 7 is 42. Subtract 42, get 0. Make sense? Is long division familiar? I mean, I haven't done it in a while, but yeah, exactly, right? Now, the good news is if you can do this, you can do polynomial long division because it's very, very similar. Okay, a couple things to recognize here. What was our remainder? 0. It's not always 0. Sometimes, like for instance, if I divided 48 by 6, well, not 48, that would work. 45 by 6, what would I do then? I'd be like, okay, how many times does 6 go into 45? 7 times. 7 times 6 is 42. Subtract, I get 3. There's nothing else 6 doesn't go into 3, so I would say, remember this? Remainder 3, because we hadn't learned our decimals yet. So we would say, 7 remainder 3. Teacher? And they'd say, yep, you got it, right? So sometimes you have a remainder. What does that mean? It means 6 doesn't go into 45 evenly, right? Okay, but if I did this with 42, would I get a remainder? No, because 6 goes into 42 evenly. 6 is a factor of 42, right? Okay, so 6 is a factor of 40,422, right? What does that mean? That means we could go back to the bigger number if we wanted to. Think about it. That means 6 times 6,737 is 40,422, right? When you divide with long division, you learn 2 things. You get an answer, and you also learn factors, right? This divided by this is this. Great, that's our answer. What else do we know? We know that this times this must be this, right? That's a very important thing to carry forward into this lesson, okay? Recognizing that this tells you multiple things. This divided by this is this. Therefore, this times this is this, right? Back and forth. Okay. All right, so a factor is that number you get when you can divide evenly, when there's no remainder. It's important. Factors are important. We've been dealing with factors for a while. So we want to know when we have a factor. Okay. All right, so let's take a look at this problem right here. Let's start this process with a quadratic that we've already done a lot of work with, right? X squared minus 4x minus 5. The factored form of this is right here. right? What does that mean, though? What does it mean that this is the factored form of that?
It means if you multiply those two, you'll get that.
Exactly. If I said 42 is 6 times 7, that's the factored form of that. I just broke it down into numbers you can multiply and get back to. This is x minus 5 times x plus 1. If you wanted, you could FOIL it and get back, right? You could go back, right? You could factor, or you could go back. What else does that mean? Go ahead, question?
Is the 42 part of that, or is that?
No, this is just another example.
Oh, okay, sorry.
Just a different example. Okay, so this is the new part, right? If this is the same as this times this, understanding what a factor means, that means that this divided by this must be this, right? Think about it. 42 divided by 6 is 7, because those are the factors of 42. So this divided by this must be this, because these are the factors of this.
So would it be 5 divided by 1?
No, we're not worried about the division part yet. We got to understand the concept. This divided by one of these will give you the other one of these. Okay? X squared minus 4x minus 5 divided by x minus 5 must equal x plus 1. Because this times this is this. Okay? And we're going to keep going, so don't worry if it's still a little confusing. Okay. So essentially what we're asking ourselves when we do these division problems is, do we have a factor? Is it a factor? Right? So let's get into it. We have this problem here. What's going on here? Okay. Where's the problem? Oh, the sheet went away. Oh my gosh, it moved over here.
Is it sticking?
Yeah, that's not hill. You're falling past it.
Okay, fixed. Okay, there it is. Okay, so now we get this type of problem. You'll get a question that says this. Divide this by this. Okay? Now I added this above because essentially what this is asking is that a factor of that? If I divide that by that, will I get a remainder of 0? Because if I would, then it's a factor. Right? If I don't, it's not a factor, right? Then if I divide this by this and I get a remainder of 0, it went in evenly. It's a factor, right? I can start to break this thing down, okay? So we're going to talk about this process in a second, but we got to be solid on the concept. What are we doing, okay? If I divide this by this, the result that I get, this result right here, it's not just my answer. Remember when I talked about dividing long division, it tells you more than one thing. Yeah, this divided by this is this, but what else does it tell me? That multiplied by that is that, right? And that's great because that means we can check our work. Every time we do long division and we get an answer, if we want to check our work, we multiply our answer by a divisor. And if we get back to the original, we did it right, right? So up until now, we have only talked about multiplication. We haven't talked about division. Now we can go both ways, right? It allows us to check our work in multiple ways, okay? Okay, now, and I'm going to come back and talk about this process, don't worry. Now, when we get a remainder of 0, it means it's a factor. Great, awesome, it went in evenly. But we don't always. Just like earlier, 45 divided by 6 gave us a remainder. There's got to be a way to write that with polynomials. That's what this next problem was, right? We had this divided by this, right? And we did all the work. And it turned out that it didn't go in evenly. It gave us this remainder at the end that we couldn't do anything with. So what do? We still write our answer. So our answer is 2x squared minus 6x plus 17. And this is how you write a remainder. You say plus the remainder divided by the factor. Because that's the part you couldn't divide. You couldn't do it. Yeah?
Could you put the negative from the 58?
Yeah, you could put minus 58 over x plus 3. Yep.
Wait, where do you get the 13 from? Where's that? Oh, x plus 3. So
X plus 3,
that
yeah.
was like a 13. Right.
Sorry. So you put the remainder over your divisor. Okay? That's just how you write a remainder. And that means it's not a factor. It means that x plus 3 wouldn't give you a good root there. Okay? But we're going to get to that part a little bit more. I want to circle back. The other thing I want you to notice here, if you're looking at this problem, this is super key. You will get the wrong answer if you don't do this. Okay? Looking at this problem, it's 2x to the third. Then it goes x to the 1. What did it skip?
X squared.
X squared. So what did I do? I put 0x squared in there. Right? If you skip anything in the middle, you have to put a placeholder in or your long division won't work. Question.
It has to go 3, 2, 1.
It has to go from whatever. If it's 4, it's got to go 4, 3, 2, 1.
Well,
You can't.
What if it was 4, 3, 2, 1, but like there's only 3 x's? Would you have to add another like? What if it was like?
You don't have to add up. Just go for your highest power and make sure you have a placeholder at every spot after that.
But I'm like saying like, what if there's like?
What if it was missing the number?
Yeah.
Just put a 0. But it probably won't matter. You probably at that point the problem will just be zeros going. But you could put a 0 and it wouldn't hurt. But yeah, you need this placeholder, otherwise your long division won't line up. Okay? So something to keep in mind. All right, let's talk about the process, because I know this is what you've been waiting for. All right, do me a favor, somebody. I'm going to just do it again over here. I'm going to start over so you can see it done. Okay. Somebody tell me what is the equation that I'm the big one?
X to the power of 3 minus x squared.
Minus x squared or 2x squared? Minus x squared.
Minus 17x.
Minus 17x.
Minus 15.
Minus 15.
Divided by 6 plus 1.
Divided by x plus 1?
X.
Okay. All right, now think back to when we divided 40,422 by 6. Did we try to do it all at once? No. What did we start with? The first thing. Same thing, right? What's the first thing we see here? X to the third. So I'm going to start with that. And not only am I only going to deal with that first thing, I'm only worried about this first thing. That's it. I'm seeing, does that go into that? That's it. Okay? One step at a time. Now, I'm going to ask a question, and then you'll be like, what? And then I'm going to ask it a different way, and it'll make more sense. But I have to ask it the first way first. Remember when you had 40 and 6? I asked, how many times does 6 go into 40? And you said 6, right? How many times does x go into x to the third?
Twice.
To the power of 2.
X squared times. And that's why it's confusing. So this is the question you're going to ask yourself instead. X times what is x to the third? X squared. So ask yourself, what times what is that? And the answer goes up there. X times what is x to the third? X squared. Just like if I had 40, I would say 6 times 6 gives me 36. You would say, this thing times what gives me this? X times x squared gives me this, so x squared goes up there. Mm-hmm. Good, yeah. All right, so we're going to do this a bunch, so don't worry. All right, now what did we do before? We had 40, we did 6, and then what did we do underneath? We multiplied and subtracted, right? So that's what we're going to do. X squared times x plus 1, right? What is x squared times x plus 1?
X to the third.
X to the third, and then x squared times 1 is plus x squared. Now, what did we do with that amount? When I had 36 and I put it under the 40, what did I do? I subtracted it. So I have to subtract this. Right? I have to subtract that away. When you subtract a whole thing like that, what happens to everything inside?
It becomes the variables change. Like
Everything flips its sign, right?
the sign change.
Right? So x to the third minus x to the third, that's canceled, so nothing. And then negative x squared minus x squared is negative 2x squared. Excuse me. When I got that number, what was the next thing I did? Like, I did 40 minus 36 and I got 4. Did I just stop? Drop the next thing down. So let's drop it down. Minus 17x. And then you repeat the process. See, it's the same thing, it's just more complicated. Okay? And don't worry, again, I'm showing you a third or second way today. So just bear with me on this. Okay, now I repeat it. X times what is negative 2x squared? Minus 2x. Right? Negative 2x times x is, that we just said, negative 2x squared. And negative 2x times 1 is minus 2x. And what do I do with that thing I put underneath? I subtract it. And what does that do to the signs?
Changes the signs.
Plus, plus. And what happens? Well,
The first one was canceled.
yep, this one cancels. And then this one is negative 17 plus 2.
So the x's count negative 15.
Yep, negative 15x.
And then you bring the bottom and the next one down.
Bring that down, minus 15. X times what is negative 15x?
Negative 15.
Minus 15. Look what our answer's starting to look like. Okay? Negative 15 times x plus 1.
Is negative 15x.
Negative 15x. And then negative 15 times plus 1, plus the plus 1 part is
Negative 15.
negative 15. If I subtract this, what happens to the signs?
Both of them become positive.
Positive, positive, and I get
Cancel, which is
0. Meaning,
Remainder.
no remainder.
and it's a factor.
That's a factor. That means that I can do this times this and get that. Okay? I know. Complicated, right? Okay. How would I check my work?
Multiplication.
Yeah, multiply that by that, and I should get that. Now, you're going to have some opportunities to practice this, don't worry. And then we're going to talk about the easier way. So don't worry. I think I covered everything that needs to be covered in this lesson. Okay? So any final questions? And again, the next lesson will have more of this. So any final questions before we move on, though? All right, so what I'm going to do, we have about 20 minutes. No, 30 minutes. I'm going to hand out today's notes. Today's notes, the warm-up is practice multiplying, practice dividing. So you're going to get a chance to practice this. Here, I might as well pull it up. Okay. So what you're going to do with these notes is multiply. Now, when you multiply this, you're going to get a result. Right? If you multiply by x squared, what do you think your result's going to be? X cubed. So you're going to have a big, long x cubed, right? To check your work, take your answer, divide by x plus 10, and see if you get that, right? So now you can check your multiplication work. Now you have a tool for that. This one, you're going to start with your division. Divide that by that. To check your work, you're going to multiply. Okay? And then I'll teach you one more thing. Okay? All right, so let me hand this out, and I'll give you some time to work on that, and I'll check your homework off while you're doing it.